So as you can see, we have a QR code there. If you're following and scanning this QR code, following by the link under this QR code, enter the chat room using your, for example, Twitter or GitHub account and start chatting, you will contribute a lot to this talk, and you will make it amazing. And I'm going to ask you, encourage you to do that, because the most active person in this chat room will win this book, the printed copy of this book. And this book explains everything, almost everything about Reactive in Sprint 5. So this should motivate you a little bit. And while you are scanning my QR code and entering this chat room, I'm going to introduce myself shortly. My name is Oleh. I'm from Ukraine, from Kyiv. And I'm software engineer, Java software engineer, I guess as you. How many Java engineer in this room? Oh, amazing, everyone, cool. So, I work for Netflix. Here we are doing some reactive crazy stuff like creating some reactive network protocol, building some frameworks on top of that. Along with that, I love to talk a lot. And that's why I'm a public speaker, and that's why I'm staying here. And what I love more is Project Reactor. That's why I'm a committer of Project Reactor and know almost everything about this project and this technology. And if you have some question about that, you may ask me after this presentation. We will talk about that, and I may try to help to solve your problem or whatever. And finally, I do my best to contribute to development of my local community by contributing to such biggest conferences like GeeCON or DevX Ukraine, which will first take place at Ukraine this year, and by co-organizing local Java user group meetups. And let's return to our main flow, to our main presentation. So our main mission for this talk is learning some basic essential steps of refactoring your old Sprint 4 based presentation to Sprint 5 and reactive stack. And in order to do that, we are going to start with learning of non-reactive application, because non-reactive application is a good source, really good source of refactoring it to reactive, right? Absolutely. And our main goal of this refactoring is achieving system which corresponds to some characteristic depicted in this diagram. By the way, how many people knows what this diagram means? What is the name of this diagram? Just one hand. Two hand. Okay. For those who don't know what this diagram means, this diagram explains of the main characteristic of reactive system. So our goal is to achieve reactive system. And you may find the explanation of those characteristics in Reactive Manifesto. So I encourage you to Google what is Reactive Manifesto to learn, to dig in this characteristic and understand why it's important for us. And finally, after the refactoring, we will achieve the system of streaming and events choreography. But this will be at the end, and right now is non-reactive chat application. You may wonder why chat application. First of all, I had some experience of refactoring and migrating some notification service from old Sprint 4 stack to new Sprint 5 stack, and that's why I decided to create a demo based on my experience. And of course, this is kind of simpler example. Our application has really plain, straightforward functionality, like consuming messages from Gitter. By the way, how many people in the room knows what is Gitter? One, two, a few hands. So for those who don't know what is Gitter, Gitter is a chat service which allows you easily build a chat room around your GitHub project. So you may wire some chatting really easy in a few steps around your GitHub project, encourage people to visit your room, to start talking, discussing some things. And this is really cool service for open source. And here we have a chat room in this service, which is under this link. just call it Reactive GeeCON 2018. And again, I encourage you to visit this link to scan this QR code. And on top of this basic functionality, we have an additional feature like calculating of the messaging statistics. So here we do some additional calculation, aggregation, and looking for the most active person in this chat room and looking for the most mentioned person in this chat room. So this is pretty it. Let me show you, first of all, our application. I'm going to start with the UI. As you can see, there is some active persons. Thank you for chatting. And what do we have there? Here we have our statistic bar. So the most active person right now is me. The most mentioned person, again, it's me. You can change it. And of course, I'm going to send a few messages like this. Of course, I did it in my language. So this application just works, which is fine. So turning back to our presentation, the main question that should appear in your mind is what is going on behind the scene? How this application works? First of all, I'm going to start with explaining the toolset or technology stack that we use here. First of all, we use Spring Framework 4, which is obvious. Then we use Spring WebMVC in order to wire some communication between browser and server, expose some endpoints, allows browser to take some information from our server. Here we use Spring Data MongoDB because Mongo is a fancy technology, why not to use it, right? And we use Spring Boot in order to really fast and smoothly start our application and configure everything in a few seconds. That's our technology stack. And now I'm going to ask you, how many people uses almost the same technology stack in their project? Just raise your hand. Cool. And Spring 4, still Spring 4 in your project, right? Cool, yeah, so you are in the right place. All right, the next point that we are going to understand is architecture of our application. So architecture is really straightforward and plain and similar to our technology stack. So here we have a user client, which is essential part of web application. And on the other hand, we have Gitter service, which allows us consuming some messages from it. And in the middle, we have our web application. So this is the central part of our system. Our application consists from few layers: controller layer, service layer, and persistent layer, right? Everyday and common architecture and technique for building our services and our application. So let me show you and ensure that we have exactly that application. First of all, let me show you that we have Spring Boot 1.5, as I said. Here we have Spring Data Mongo, Spring Web. Actually, nothing special there. And here we have our core part of the application. So here we have controller layers, a few controller, our domain layers, a few domain objects like representation of MongoDB documents. And here we have repositories layer, or a way of communication with database using Spring Data. And here we have some business logic or business service layer, where we have some implementation of communication with Gitter chat, with statistic, and some configuration. So that's pretty it. Here we have our Spring Boot application. So nothing complex there, right? And the final point that we have to understand in order to understand why we have to refactor this application is execution flow. So execution flow is really common. We open our browser. This initiates the first call to our server. We start collecting some data from the Gitter, right? We have to call to Gitter, wait a little bit, and then we have to wait while it sends response back. And then we have to store our messages to database in order to do some statistic calculation We have to wait a little bit, and we have to recalculate statistic because database state has changed. Thus, we have to call and do some query again. Finally, after all this calculation, collecting of data, we may send the response back and render something on the screen. Along with that, we have really little part of JavaScript, and this JavaScript does almost the same as the main execution flow. So it calls to getter, collects some new messages, store them to the database, recalculate statistic again, do everything every few seconds. Do it again and again and again and again and again. So this part just update our messages on the screen. So let me show you. Let me show you a code a little bit closer. So here we have our template, our HTML, where we have some template part, configuration. I'm not a JavaScript developer. This is code a little bit ugly. But what do we have there? First of all, we have cursor, which is state of the latest messages that we got from the server side. Here we have some execution of the call to our controllers. In order to grab new messages, we send the latest message IDs that we have in the browser, stored in the browser, and we repeat this action again and again and again and again and again. So nothing complex there. Along with that, we have a controller part. First one is part that handles the first execution, the first call to our server. So we handle the first call, get the first initial message back, then we store these messages to the database, put everything in the model, and say render this template file. Along with that, we have some resource controller there, which does almost the same. So this is get mapping, which returns some messages in order to get some new messages. We do some pooling, so we call the same method in order to get new messages right after this cursor. Store the statistic then, do some coding part, storing of the data, changing the representation, and then send the response back. So this easy part. Finally, the final part that I'd like to show you is, not the final, but almost the final, is communication with external getter service. So in order to do that, we use REST template there. So we use REST template, prepare some call, execute that call, and receive the response. That's easy, right? And here we have some implementation of statistic server, which interact with repositories, do some queries to the database, like we have some custom implementation of the query because it's a complex query, like aggregating of the data. But that's fine. It doesn't matter for our presentation, but you have to learn that part as well. Okay. To summarize, in general, about our application. First of all, this is everyday Spring Boot application, right? In principle, there is a standard technology stack, standard architecture, so nothing complex there. Everyday plain 3-tier architecture in our stack, and really common interaction flow. I guess many people in the room does communication using REST, right? How many people use REST in order to wire communication between browser and server? Cool. So this is really common technique of doing communication between client and server. Finally, it's the most important part. This application just works. So what I'm doing there? I am talking about refactoring if it works. So what's wrong with that application, right? I have a few concerns to this application. First of all, it's a pooling model. And pooling model might be explained like this.
Mom! Mommy! Mommy! Mama! Mama!
And this again and again and again for nothing. And yeah, this is fine, this is fine, this is fine. This is really common technique of doing some updates and etc., etc. but it doesn't work if we have the jar of the same. Yeah, in general it doesn't work. And it's fine because we do some, like, pull-in model is fine. Even if we have some drawbacks and unclear architecture there, it's fine. But the more evilness part is blocking I/O. Because blocking I/O is a pure wasting of resource. Instead of doing request, freeing the thread and doing in this thread something useful while the request is sent into the external service, we have to block our thread and block other users and mandate them to wait while another users are doing some request to the external service, to the database. And that's the really terrible part. But yeah, this makes our application work. The only things that breaks our application in general is some kind of unresponsiveness. I'm going to show you that. For example, let's imagine what happens if our database became unavailable. So here I have a Docker image of MongoDB which is running right now, and I'm going to stop this image and emulate some outage of the database, which is common situation in the real world application. And once I do that, I'm going to restart our application. We will see the error after a few seconds. And the error is really bad practice and really bad experience for any application that exposes UI to the user, because users don't like seeing any errors. Of course, we have to wait a little bit because it's some timeout and so forth and so on, but this doesn't work. We can't, it's unacceptable to show error, and in order to provide some resilience to our application, we have to bring a lot of additional libraries, provide some workarounds and so forth and so on, and we can't easily implement resilient application using synchronous and default blocking technique and using Sprint 4. And this is a problem. And knowing that we can do better, I'm really saying that we can, like, this doesn't work. So the first step, of course, the answer to our problems is reactive. And in order to start moving to reactive, we have to refactor our design, or in other words, change our mindset. And we have to change our understanding and start reacting to the events instead of taking and asking for them. So we have to react to new events. This is the essential part of being reactive. And in order to be reactive, we have to change our model, first of all, from pull to push. And finally, in order to be resilient, we have to isolate our components. And by doing that, we will be able to stay responsive to our calls, to any problems that occurs during the lifetime of the application. So this is an essential part of being reactive, but this is not enough. And this is not enough because we have to have some technology. So the main question, how to be reactive? And the answer is really simple. With Sprint 5, right? And especially with WebFlux module. By the way, how many people has already heard about this model? Just raise your hand. Okay, a few people, a few hands. For those who didn't hear about that project, WebFlux is the same WebMVC, but with some additions. So first of all, let's recap what is WebMVC. So in WebMVC, we have default controllers which we are using in order to build our web API. Under the hood, everything is powered by Spring MVC module. It's running on top of Servlet API and powered by Servlet container like Tomcat or WebSphere or whatever enterprise container. WebFlux is almost the same. So we have the same API, we have the same controllers annotation, request mapping, which is powered by new Spring WebFlux, which is built on top of new reactive stream API, which allows us using almost every server engine. We may use servlet containers in order to run our application with WebFlux. We may use Undertow, or we may use Amazing Netty. So in order to run everything and make everything reactive, WebFlux under the hood uses Project Reactor. And how many people heard about Project Reactor, by the way? Okay, a few hands. How many people heard about RxJava? So Project Reactor are similar to RxJava, and in general, Project Reactor allows us writing this amazing code. So we may write this clear declarative flow of transformation of the events, which absolutely non-blocking and asynchronous. And what you have to know about Reactor is just a few reactive types. First one is mono. And mono allows you to process 0 or 1 elements asynchronously. So mono is similar to completion stage, but better. And the second reactive type that we have in Project Reactor is Flux. And Flux allows us processing infinite amount of elements. And of course, Flux is similar to Stream, which we have in Java 8, which we got in Java 8. But again, it's better. It's much, much better. Along with that, all those reactive type is built on top of something called publisher. It's a base interface. It's a part of reactive streams. So don't worry. You will see this reactive type in our code session later. But just bear in mind that this is related to reactive type as well. So let's do the first reactive and let's do the first migration of our application. Let's bring new technology stack. So I don't like to waste your time. That's why I'd like to emphasize only the important parts of migration, and that's why I'm going to switch between commits. And by doing that, we will go in by sprints, providing some. We're going to provide some additional implementation during our migration, and going to learn what has changed, what we have to remember during the migration. So first, let's try to understand what has been changed in our build tool, in our build script. First of all, we have changed the old Spring 1 to Spring Boot 2. That's the essential part, because Spring Boot 2, only with Spring Boot 2 available new Spring WebFlux module, which is here. So in order to get Spring WebFlux, you have definitely migrate to Spring Boot 2. And of course, along with that, we have some migration. We have huge changes in our implementation, which looks like that. Only one line. There is only one changes in the API, like breaking changes, that which requires some coding. So we have to change old save to save all methods, and that's it. Nothing special. First of all, let's check whether it works, because it's an important part. Let's build our application. Yeah, it builds. And let's restart it. So as you can see, now our application is running using Spring Boot 2, which is fine. And one may wonder, where is Spring 5 there? And I will say that Spring 5 is a default dependency of Spring Boot 2. So by bringing Spring Boot 2 into our project, we are bringing Spring 5 by default. So here is Spring 5, and here is default stack of Spring 5 core modules. So don't worry, Spring 5 in place. All right, let's check our UI. Let's turn our database to life again. And let's reload our application and see whether everything works. Yeah, it works. Cool. So we did our first migration steps. And in order to be reactive, we have to use Spring WebFlux, which is amazing new technology stack. We have to use project Reactor in order to write clean, asynchronous, and non-blocking code. And we have to change just a few lines during the migration. And yeah, we migrated to Sprint 5. We're amazing. But that's not enough. First of all, we have to change everything, almost everything in our application. And we have start with a change in our API, because API is an essential part in communication between client and server. And what's wrong with our API? First of all, we have a common REST. And as you might remember, REST is stateless, right? That means that the state is held at the browser side, and in order to get new messages, browser have to ask almost the same queries to our API, send call with the same cursor ID, collect some data. So our service doing the same work for every browser. And this kind of wasteful. How do you think? Can we do better? Of course we can. Let's analyze what we can do regarding that. First of all, the state is here. And every browser call for the same messages, do the same job. So why don't we move that part to the API side? And API side, once receive the connection from the browser, provide some continuous connection and pull messages separately from the browser and then broadcast new messages to each new connection, right? We can do that. However, it has some challenges. First of all, the main question, how to make server-side push? Or how to manage the subscribers, because now we have to manage each subscribers on the server side. We have to manage how to whom we have to send new messages, to whom we don't. And how to provide some pooling management on the server side, right? Fortunately, I have a few answers to these challenges. First of all, we may use server-sent events. How many people knows what is server-sent events? Okay, server-sent events is a part of HTML5 and allows you easily to wire continuous connection between server and client. So you may wire connection, one side kind of one-way connection, but server can push messages to the client, to the connected clients. So we are going to use this technology, which is standardized in HTML5. Then we are going to use some part of Reactor technologies and Reactor toolset. For example, we are going to use reply processor, which allows us easily provide some broadcasting subscriber management. Plus, it allows you to do some caching and configure some caching of the messages, which is also additional amazing part of this tool. Finally, using some combination of operator, which is part of Reactor as well, we are going to achieve a really efficient pooling model. So let's do that. Let's see what we have to do in order to achieve these technologies. We are working hard during new sprint and finally provided new changes to our project, and now we have to analyze, do some retrospective of our changes. First of all, let's start with the most important changes in our project. And this part related to the resource controller, because our browser connects to our API and grabs some new messages. And here, unfortunately, we have to rewrite almost everything because we have to change our model from pulling to pushing. However, I would like to emphasize only one thing here. Let me open it here. The most amazing part that in order to wire streaming functionality, we have to use the same Spring WebFlux feature. So we have to annotate our method with the same get mapping, and instead of returning some static synchronous type, we may return stream or flux of messages. And as you might remember, flux is infinitive stream of messages. And the rest of the changes is changes in our providing some pooling model. So here we held our cursor ID right now, and here we do some reactor transformation, and here we do some pooling. So here we call the chat service as previously, and so forth and so. Don't worry if it's unclear for now. Right now I'm going to explain how it works. So this part of the code is what we did a few moments ago. And by running this code, we are going to build this execution flow. And first of all, what is going on? By running our application, we are going to supply the initial cursor ID. So like that. And here, delay operator obviously delay messages asynchronously, non-blockingly for some time. And once we receive this cursor ID in the do on next, we are going to do some pooling. So we are going to pool new messages, store them to the database, and then using Flux sync, this is a part of Reactor, we may manually supply messages to the stream. So the amazing part here that Reactor provides us almost with everything that we need. It provides us with a stack of amazing operators, along with the ability to supply messages manually and manage how we want to send messages to the stream. So using Flux sync, we may supply messages to our reply processors and cache messages here. Then, for example, we may send and supply new cursor ID once we did it, like once we collected new messages, we may supply to ourselves new cursor ID again, and delay it for some time, and pull again. Now suppose that we have some outage of the service. For example, we start pulling and our database is unavailable. So we pull in, and we crashed. Fortunately, Reactor offers a fallback for that. It offers retry backoff operator, which allows us to retry failed action, run the same operation again, and eventually we may got our messages and supply it again to reply processor. Amazing, I like it. I really like it because it's one library solves a lot of problems, and this is amazing. So, okay, what is going on the other side of our communication? So this was one part, communication with database, communication with Gitter, and the other part is sending messages to the client. So first of all, we don't have to manage our connection and subscribers management because it's done by Reactor, by reply processor, as I said. And all we have to do is just merge our stream of messages and send them to the browser, and that's it. Few lines of code in order to merge a lot of messages, infinitive stream of messages, and send them to the browser. I like it. I really like it. And let's do some summarizing of our refactoring part. And first of all, by doing this optimization, by providing some pooling mechanism on the server side, by taking into the place Reactor, we improved our resource usage. This is the first benefit. The second benefit, in order to provide some caching, we don't have to write and bring some external technology. We may use just Reactor, and that's it. And in order to broadcast messages, we may use reply processor, which provides this feature out of the box. That's cool. That's amazing. Actually, I like it. First of all, we have to check whether our application still works. Let's rebuild it. After these changes, let's restart it. And let's clean the caches because this is JavaScript and HTML and browser. And first of all, let's check whether we have a continuous connection there. And here, as you can see, we have a stream of messages. And if I write something, it's going to appear here. Yeah, it's continuous connection. So one connection to the browser in order to achieve new updates from the server. That's much better. And right now, what's happen if we stop our database? So let's stop our database. Let's reload our page again, and it works. Of course, there is some downgrade and we still see some messages, but of course the messages doesn't appear because database is unavailable. But once we enable database again, the messages start appearing again. And this is much better because now we provide better user experience because our application doesn't show any error messages, and this much better. So by applying these changes, we may achieve better user experience, better resource usage, and so forth and so on. But as I said, this is not enough. We may do better, and we may do better in case if we remove all blocking evil operation. So our communication, in essence, must be non-blocking. And the main challenge here is achieving end-to-end asynchronous and non-blocking communications. So how we may do that? First of all, we have to follow a few rules. In case if we have in our communication between components some synchronous type like object, we have to change object to mono of object because mono is asynchronous type, an asynchronous communication, asynchronous contract. And in case if we have some collection of message as return type or input type, we have to replace it with a flux because flux is a stream of messages, right? However, there is some exclusion from this rule that we are going to see a bit later this presentation. When we are going to move from pooling model to push model, we have to change object to stream of object because previously we took some message, one message, and now we have to listen to changes. And instead of taking some messages, we have to listen and receive a stream of messages. So along with that, the interface and communication part, like between components in Spring, is exposed as interfaces as well. So in order to communicate with database, we have to use Crud repositories. Unfortunately, Spring provides some replacement for synchronous Crud repositories, which is called reactive Crud repositories. And reactive Crud repositories, which is the most important, is built on top of Reactor. So we may just migrate this interface Crud repository to reactive Crud repository and achieve reactive communication with database. Then the next question is how to communicate with external services. Previously, we used REST template. And Spring WebFlux offers us web client, which is built on top of reactive type as well and offers us asynchronous and non-blocking communication with the network. So this is pretty it. We know how to change our API, how to change our implementation, and now we can do that. We may work hard during the sprint, and finally apply all the changes in place. And let's do some analysis of our changes first of all. Let's start with analyzing of changes in our build script. First of all, in order to achieve reactive communication with database, we provided new module, which is out of the box module, which is called Spring Data MongoDB Reactive. And Spring Data MongoDB Reactive provides implementation from reactive Crud repositories and allows us to communicate with database, with back pressure, with streaming semantic, and so forth and so on. Along with that, let's analyze all changes related to the database. In order to bring some new reactive stuff, we just have to change one line of code. Like here we had Mono repository, and now we have reactive Mono repository. So nothing complex here. And even if we have some complex queries that was there, we don't have to change like everything. We just have to change Mono operations to reactive Mono operations. And first of all, the most important part that aggregate now returns flux, but since we have to take only one element, we may say that this is mono. So instead of flux, we may convert it to mono and return it as a return type. So that's pretty, just a few lines of changes there. Along with that, we have some changes in the communication with external services. As I said, we had REST template, which is replaced with web client. Of course, we have to learn new API there, but in general, web client allows you to do some asynchronous non-blocking communication like this. So here we return mono, and that's pretty it. Also, we have some changes in our communication with database, because now we have to use Reactor for our communication. So here we save our list of messages, then return instead of synchronous type asynchronous type. Here we do the same, like previously we had synchronous type, now we have asynchronous. And also we have a list of changes at the controller part. Oh, sorry. So here we have some changes in the pooling mechanism, but this is fine. This happened because we moved from synchronous blocking communication to asynchronous, and we have to adapt our code to new Reactor, tool set. So first of all, let's try to build our project again. Let's restart it. And let's check whether it works. This is the most essential part and important part of checking. Of course, you can be Chuck Norris and you may push to master and to production, but we have to check and build it locally. So it works, it runs. First of all, it runs on the same technology stack like we used Tomcat there. Nothing has changed even if we use new Reactor and WebFlux module. We may run our project on the same technology, on the same server engine like Tomcat. And now let's restart our project and check whether it works. Yeah, it works. Amazing. I like it. So let's do some summary of this part of migration. Let's do some retrospective. And first of all, by applying non-blocking communication, we improved our resource usage again. This is cool. We can save more money by improving resource utilization because we use our server more efficient. The second part is now we achieved reactive end-to-end because we use web client which provides asynchronous non-blocking communication with external Gitter service. We provided asynchronous non-blocking communication with MongoDB, and this is cool. Finally, in general, the migration is really smooth because we don't have to rewrite everything. We have to follow the rules that I mentioned previously, and by doing that, we will achieve reactive from end to end. However, this is not enough, again. This is not enough because we can do better. And in order, our main mission was achieving streaming application. This is why we have to change our model from pulling to push model. Now we have to rewrite part of our application and start reacting to the events instead of checking and asking for them each time, each few seconds. So how to achieve that? First of all, we may apply and we may use Gitter push API. Fortunately, Gitter offers this possibility. And instead of pulling messages, we may connect to the Gitter via some continuous connection and start listening to the new messages. So let's apply these changes. Let's do almost the final migration of our application. First of all, I'm going to show you a few changes in the communication with Gitter. Here we provided some additional method which allows us to connect to Gitter and to Gitter streaming API, start listening for new messages, and this pretty it. So along with that, we have some changes in our controller as well. Here, instead of using hard, complex pooling mechanism and chore of some additional Reactor operator complex interaction on transformation, you may just start using plain clear flow of listening to the new changes, merging of initial stream part of messages with the stream of messages. Then using this operator, we are going to publish or broadcast messages between two consumers. We are going to explain this a little bit later. Don't worry if it's unclear now. But here we send some messages to the browser, and here we send some part of the messages to the statistics service. And now, instead of receiving the synchronous type or the list of messages, we receive the stream of messages. And doing some transformation on top of this stream of messages, provide some storing to the database, apply some transformation, and instead of pulling messages, now we react to the changes. And this much better. So let's go into reload our application. Let's go into to restart it and check whether it works. Cool. It has started. That's amazing. Let's restart our page again. Yeah, and we receive messages here. So now we have to check whether we improved the responsiveness of our application. Let's try to turn the Wi-Fi and emulate some network outage. Let's try to restart our application, and it works. Okay, what happens if I stop database and reload our application, and it works again? Okay, let's turn on the Wi-Fi again. And now I won't reload the page. And as you can see, we are started receiving messages. I can write messages without the reloading the page, without the restarting of the server, and new messages still continue. We're still receiving new messages. Of course, we have to run our database in order to receive new updates and store new updates to the database. And by doing that, all the messages will be stored without losing, because we have some part of the code in the Reactor which provide us with that ability. Okay, let's back to the slides. Let's try to understand how this part of the, how these changes work and how now our streaming application works. First of all, this part of the code will build the following execution flow. By calling those two messages, we are going to wire two connections. First one is request response connection, so we will receive the list of messages there and store it in our reply processor. Once we do that, this connection will disappear, and eventually we will get new updates in the continuous connection, which will be published to the statistics server and to the reply processor and sent to the browser. On the other end of our stream, we have publishing of the messages or sharing of the messages. So these messages will be shared between statistics servers, which will provide us with new statistic updates, and some part will be stored in the reply processor. So by applying all of these changes and take a look in general to our application, we will see that now we have fully streaming application. We listen to the changes in the Gitter service, then we send those changes to the business logic, to the database. Database provides us with new updates and everything like a pure stream of events. So that was our main goal, and now we achieved this goal. However, we may do even better again. First of all, we may do better by moving from Tomcat server, which is not efficient enough, to Netty server. How many people knows what is Netty, has had some experience? So a few hands. So in general, Netty is a synchronous event-driven framework, and the essential part of Netty is asynchronous and non-blocking from the core. So it's pure asynchronous, non-blocking reactive server engine, which is based on something called event loop. What does it give us? First of all, it gives us really high throughput application. So Netty uses almost for this for high-throughput servers in order to build high-throughput and low-latency servers and application. And it provides us with really efficient resource usage. To your understanding, one Netty can replace 2 Tomcat servers. I did some measurements. It's naive measurements, but for my case and for my measurement, I received like 2 times. I got some 2 times improvement in performance and latency, and can handle 2 times more user requests in the same server machine. So let's do the latest changes. We are running out of the time, of course. Just a few minutes of your time. So let's update it. And let's restart our application. And see whether it runs on top of Netty right now. So here we have Netty. Woohoo! Now we are going to run on top of Netty, and in order to run on top of Netty, we have to do only 1 changes in our code. We have to remove web module, because in combination of WebFlux and web module, Spring Boot knows that now we want to use old servlet-based servers, and in case if we want to use new reactive server engines like Netty, we have to remove web and say, we only want to use WebFlux. And by default, WebFlux brings Netty as the main server engine. So this is the only change that we have to apply there. Now we are going to restart our server and achieve super fast and high throughput application. Okay, let's do some final checking. That was our main goal. And now let's check whether we are there. Are we resilient? Yes, we are, because we can stay responsive even if we have some outage in the network, even if we have some outage in the connection with database, and that's cool. We are message driven because we are using Reactor, and Reactor provides us with ability to communicate asynchronously and non-blocking and message driven. And only by applying those 2 changes and those 2 characteristics to our system, we can be responsive, which is the most important part of our system. One part and one characteristic is left unclear is scalability or elasticity. And I have an answer to that question, and this answer is called RSocket. How many people heard about RSocket? 2 people. So RSocket is a new generation of streaming. We are building at Netify RSocket, which is new protocol and new communication between services. And it allows you to use the same streaming semantic in order to send messages between service with back pressure and different streaming abilities. In order to achieve and build our application, we can use Proteus project which is built on top of RSocket, and Proteus project is well integrated with Spring, and we can do that really easily in a few steps. This is another story, and this is just another talk which we are going to give at Devox Ukraine this year, and yeah, we may talk about that later. First of all, oops, this is not it. This should be hidden. Let's check the main disadvantages of this technique, because we have to understand a lot of the advantages, disadvantages, because we are developers. First, the main disadvantages of this technique is understanding. And there is some learning curve that we have to do in order to start understanding how Reactive works, how Project Reactor works, and so forth and so on. The second part is sometimes we have to rewrite everything from scratch. And this is sometimes unacceptable for big enterprise project. And finally, debugging is a challenge. But the answer to debugging is provide more testing. And you may start writing more testing with Project Reactor test module, which provide us a way for easily writing the test cases using reactive streams. However, along with the disadvantages, we have a lot of advantages. And the main advantages of Reactive is Reactive System, which we may easily achieve with the same Spring framework. And by doing that, we can improve our throughput and performance of our application and improve resource usage. These are the main advantages of these technologies and this technique. I would like to add one more thing to our talk. I guess a lot of people wondering what I can do if I have JDBC in my project. How many people use JDBC in order to communicate with their database? So a few people. I have an answer for you, which sounds like R2DBC. R2DBC is Reactive Relational Database Connection. And R2DBC allows you communicate asynchronously, non-blocking, with back pressure, with the same relational database like Postgres, like MySQL, H2. And R2DBC is one of the pivotal projects. They provide integration, with Spring Data JDBC right now. This project a little bit fresh, but this is a new generation. Of course, I guess you heard about ADBA from Oracle, but ADBA is not good enough. And RTDBC is much better. So we have to look after this talk to this future. And if you have any other question related to R2DBC, you may ask me about that backstage. But finally, I would like to share a few resources to start learning about Reactive. First of all, in order to understand the sense of Reactive, I would like to encourage you to read this small book about Reactive. Then you may play with WebFlux and do some workshop from pivotal guys. Play more with Reactor, because the Reactor is an essential part of reactive stack in Spring. And finally, you may learn really production stories from Netflix, which uses Reactive everywhere in their technology stack and in their servers. This is pretty it. Thank you for coming and thank you for listening, and have a nice day. And final part is book giveaway. So the most active person is Voito. I'm not sure who is. I'm welcoming you to come here after this talk, and I will give you a book. So again, thank you, and have a nice day. You may find presentation and code by following this link.